Hello and welcome, and thank you for joining us on this live webinar. I'm joined by Gil Sever, who is the CEO and co-founder of Applitools, which is the leading vendor of visual testing solutions. I'm Matthew Crabbe, I'm the CEO of QA Financial. And of course, our particular focus is on how exciting new technologies are being used and can be used by financial services firms. And that's very much the focus of the conversation I'm going to be having with Gil over the next 45 minutes. So I've got some questions for Gil. Gil's got a presentation as well that's going to help us dive a little bit deeper into the technical topic of visual testing and also some of the trends that he sees emerging in technologies that financial services firms can apply, particularly autonomous testing, to do with autonomous testing, and how those relate to technologies that we're also seeing, say, in the automotive industry, for example, how those compare. So a lot of ground to cover, and there will be time for your questions. So please do, if you have a question for Gil, just write it into the Q&A section and I'll be able to see it and I'll be able to ask him. We'll leave time for those. Gil, welcome. Thank you for joining us.
Thank you for having me, Matt.
And let's not waste any time. Let's dive straight in. I'm really interested to hear, when you, a CEO of a very innovative company, when you're talking to customers that you have in the financial services vertical, what are the pressure points they're telling you about? What are the challenges, the key challenges that your tools can help them address?
Yes. So first of all, financial services are, the financial sector is the largest sector for Applitools, and we sell and service the top banks in the US. I'll show some numbers later on, but basically the most common use cases are making sure that online banking is flawless for millions of users around different geographies using different devices from desktop, laptops, tablets, and mobile devices to access their their bank, mostly doing both online transactions, using brokerage services, and making sure that the user experience is flawless. I think this is like the main use case that we see. But there are also unique challenges in the financial industry, like compliance, making sure that everything that is or needs to be presented to the customer in terms of warnings or getting his permission to do certain actions exists and visible on each device, on every screen size, etc., that is not being cut or eliminated on specific browsers or devices or screen sizes. That's the other thing. And all of that with maintaining very high security. We are now shifting to cloud services. And when we started 7 years back, moving to the cloud was a big issue for banks. It still is, but the need to ensure very high security is critical also for testing, and that's the other thing that the infrastructure needs to provide in all these use cases. You're on mute, Matt?
Yeah, apologies. You mentioned brokerage companies as one example. I guess it's a really great example here because, of course, compliance is driving an increasing volume of forms that need to be checked, forms that might be in, say, PDF format that gets sent out to customers. Those customers also have to have a flawless experience when they're executing trades, and they're getting not just the confirmations, but they're getting their accounts. I guess that's one example, but there must be many other across all sorts of different financial verticals.
Yes, you're absolutely right. We see that the forms on both online forms and other documents, PDF documents, talking about banking. So everyone knows what W9 or W8 forms are and how many variants they have, like W8 for companies, for individuals, and how often a specific field is added or deleted from one of these forms. And in this process, a lot of time when you touch one field, other fields are being affected, and you need to automatically validate that nothing is missing, everything that needs to be there exists, and even that certain fields are being filled by the user and not just left unused, etc. So we have interfaces to all those devices that I mentioned, but when we're talking about documents, we can also upload any type of image or document and put it to the test of our visual AI engine that validates that everything's okay when forms are changing or fields incorrectly, etc.
And I think that's a great point for us to dive into your presentation, Gil, where I know you're going to explain a little bit more about how that actually works in practice. Please go ahead.
Okay, thanks. 1 second, let me share my screen.
Perfect.
Yes. So I'll start first of all with, who are we dealing with? And as you can see here, we're dealing with 6 of the top 10 banks in the US, 4 of the top banks in Canada, 4 top banks in Asia Pacific, and additional banks and insurance companies, which are we also see them part of the big financial sector in US, UK, and rest of the world, EMEA, and other places. And I mentioned the top banks because it shows the capacity or the capabilities of expansion and dealing with very complex websites and applications that these banks are using, because they're not only the biggest financial institutions, but they're also, in many cases, use the most advanced technologies, and actually being a technological startup as well as a financial institution. As I mentioned, the most common use cases are flawless user experience across devices, regulatory compliance, and validating completeness and accuracy of documents and forms. But the reason or the value that we bring, and I'll talk about it in a minute, why we bring very unique value to financial institutions is because with visual AI, which is the best AI, and I'll explain later why, to deal with testing, we can offer a lot of advantages, from being able to author tests with significantly less number of lines of code, because we do the assertions and testings and validations through the AI, not through a code and scripts. We also offer, in order to make sure that user experience is flawless on different devices and browsers, you need to render, either to run or to render the tests on all these different combinations. And I'll show later in a survey how many combinations we're talking about. It's in average more than 1,500 different combinations. And we've developed a very unique rendering technology that allows us to run this process 20 times the execution of the test, 20 times faster than with common browser farms or device farms in the cloud. And that really allows developers to test changes that they want to deploy in a matter of minutes instead of hours, which allow CI/CD get into the banking world. Visual AI also provides better application coverage and detects more bugs than when you're using traditional testing scripts, because AI tests not only things that you define for it, but actually looks at the application and thinks, is everything okay, or is there something wrong, without you asking him to test this field, test the other field, and well, the test coverage depends on your definition. Here, AI defines the boundaries of what it can test, and as it is a learning thing, eventually we get to much better coverage and detecting more bugs. The fact that we use visual validation also helps us to show bugs that we detect in a visual way, which makes the review of test results much faster and easier. And the test managers or the QA managers can actually spend much less time evaluating test results and deciding if the application is good to go or needs to be further modified or corrected. And also, and I'll show that a bit later, providing automatic maintenance. So one of the things that we are all aware of, that in the software world, everything is changing. I mean, no application remains the same for a long time. There are always new features, new capabilities, new additions. And the question is how to keep the test coverage and not reducing it when the application changes. And in most traditional test tools, that causes a lot of the tests to break, and it takes time to fix the tests to test those new features or new changes. With visual AI, we allow automatic maintenance. So when a bug is detected or when a change is detected and the QA manager approves that this is an intentional change script is automatically being changed. No user intervention is needed. By the way, this is one step towards autonomous testing, which I'll cover later on, but that's another advantage that we offer. And because of all these advantages, as they accumulate, financial institutions manage to shorten the release time, the software release cycles by 3x. So, you know, we talked earlier about 20x test execution, but here we're talking about 3x faster release cycle, turnover time for changes in the applications. And last but not least is the security, especially moving to the cloud, which is, again, the big trend that we see overall in software today, moving on-prem software to the cloud, which was a especially delicate and important point for financial institutions. And with the way we do the rendering and testing, it's the only test cloud platform that doesn't require reverse tunneling into the organization, thus providing utmost security that is what banks need. And that's why we also see a lot of adoption for our cloud service and moving from old on-prem installations to cloud solutions. So these are the things that we see. And just to give some visual explanation about how we do it and how the platform is implementing that. So we have an integrated test cloud platform that includes few engines and capabilities. First one is EYES, what we call Applitools EYES, which is the visual AI test engine. And I'll show in a bit what it can do. Then we were talking about running the tests on different browsers, devices, and print sizes. So we provide what we call an ultra-fast grid that allows the rendering 20x faster on hundreds of browsers with stability and precision. And recently, we just launched a month ago, the native mobile grid, which allows testing of native mobile applications. The Ultrafast also allowed testing web applications on mobile devices, but when it comes to native mobile application running in the cloud, we added this additional building block, the native mobile grid, and it allows 10x faster execution than on real devices or real device clouds for test execution. The visual dashboard, which I'll show you in a minute, allows this reduced analysis of test results, where you can analyze the results of thousands of tests that you run, also in a matter of minutes, by the QA manager that eventually decides if a specific release or version is good to go. And the last point, which is super important, is actually the ability of such a platform to integrate with both the testing assets that were already developed by financial institutions and any customer for that matter, and with the DevOps infrastructure that any organization has. And I'll explain. Today, companies that use test automation use many different frameworks, from script-based open source of Selenium, Appium, Cypress, Playwright, TestCafe, XCUI, and others. And what we allow with more than 50 SDKs that we've developed to add visual AI to those existing tests, so that all the effort that was invested in developing testing so far in the organization is kept, only enhanced by the visual AI capabilities, and again, and later on, by the execution speed that the ultra-fast grid and native mobile grid provide. We can also, those frameworks also allow us to interface codeless testing tools like Mabel, Testing, Tosca, and others to the visual AI engine, and allow also companies that use some sort of codeless testing, or by the way, companies that use CMS systems like Adobe CMS, etc., to test things with visual AI seamlessly. So that's the framework SDKs. And the other thing that is super critical is the other DevOps infrastructure that every organization has, from CI/CD servers, Jenkins, and other types of CI/CD servers, code repositories like GitHub, GitLab, and others, bug tracking tools, Jira, and others. I mentioned the content management systems, and of course, chat and email, whether it's regular email or Slack or anything else, to allow further collaboration. And we are now adding integrations to design tools to make sure that the user experience is as not only as developed, but also as envisioned and designed by the product managers and the designers. So this is how our cloud is built, and everything. This platform is entirely a cloud platform which resides in the cloud. And these are a few examples of how results look when visual AI is trying to detect issues. On the right, we see an example with, again, an online newspaper where we see pink. That's where we detect bugs or issues. And here there were bugs that refer to the size of elements that are not spaced enough and covering each other. And that's how we highlight the results. But it's obvious that you don't need to analyze log files. You can take one look, the QA manager takes one look and understand where the problem is. In the center, we see an example of a financial native mobile application where we detect specific differences or changes in what needs to be shown. And again, every time we detect such an issue, the QA manager that actually reviews the test results can define whether the identified changes are a bug. And if that's the case, it automatically logged into Jira and reported to the developers for a fix. Or if it's an intentional change, like we've added a new button or a new screen, and in that case, it goes directly to the automatic maintenance and changes the test scenarios for the next runs. And on the left side, we see an example where a form is being tested. In this case, like a user bill for telephony services. And again, making sure that all required fields and information is there. So that's just to give a little understanding on how test results looks with visual AI and what it allows to detect. Again, this is a schematic of the test clouds, the way we render very quickly any specific screen on different browsers or mobile devices by taking a screenshot or a snapshot of a screen. The DOM, which is the CMS and the CSS and HTML, if it's a web application, and other parameters, if it's a native mobile application, sending it to the cloud one way, as I mentioned, very secure, no back gateway to the enterprise, rendering it 20 times faster than it takes to execute all those tests on all those different environments in traditional test clouds, and making the visual analysis in the cloud as well. So that's a very high level schematics, how the grid, both the web grid and the native mobile grid work and accelerate execution time. And finally, I just want to show, because people, when we're talking about visual AI, one question that often arises is what's so complex or complicated in finding differences, etc. So just to take a real homepage of a company, again, from the financial sector, and compare the rendering as it looks on Chrome here and Internet Explorer here. And if we just toggle between these two screens, we see that even though the information and the user experience is almost exactly the same, and I'll talk about what's different in a minute, it looks very different. And the smart thing here is not only, or with testing in general, is not only to detect all the bugs, it's sometimes more even important to be able to not to have false positives, not to mark no bugs or no issues as a potential bug. Just to give you an example, we're talking about, and in the financial institutions, we have several examples like that of large financial institutions that runs tens of thousands of tests per day. So assume 10% false positive rate would give 10,000 logs of issues that someone like the QA manager needs to go over manually and decide if it's a bug or it's a false positive, etc. And even if those tests can be run in 20 minutes, the analysis time can take of 10,000 logs can take 3 weeks. So the very strong, I would say, advantage of visual AI in that case is and again, this was based on learning of more than 2 billion screens today, is to get to a false positive rate of 1 in a million, 99.9999%, which after running 100,000 tests would result in maybe one log to be analyzed, which can take another 10 or 15 minutes. So we see how those differences are being ignored, but at the same time, there is a difference, which we see here in the bottom right, which is meaningful. So, and I'll just show it. In Chrome, you can see that there was text in that element, paychecks, etc. And when rendered on Internet Explorer, the text is missing. And this can be the add to cart or the execute my financial transaction, etc. So visual AI can ignore differences that don't matter to the human eye and brain, but detect the ones that are important. And on top of that, with the integration to the code repositories, visual AI can automatically and immediately point the developers to the HTML and CSS files that are responsible for that difference, so that now reproducing the bugs and fixing them becomes a no-brainer, a very easy task. The developers are immediately directed to the area that they need to fix, and that saves a lot of time for the developers, in addition, of course, to accelerating the testing, etc. So that's kind of like what we're getting. I'll stop here because, again, let me know, Matt, if there are any questions or things that you think I should elaborate on the things that I mentioned so far.
No, thanks, Gil. That's great. One obvious question is what is the take up like among financial firms of exactly this kind of technology? Are you seeing demand growing rapidly for this?
Yes, we definitely see growing demand, and again, in certain banks I mentioned the online services and brokerage services. So one of the I would say typical growth patterns that we see with financial institutions is that we start with a specific branch or a specific group that is responsible for certain applications. Most often, it's the out-facing applications that are at the highest priority, but we see a lot of utilization then goes to other groups that also use it for internal applications, etc. And as I mentioned, like from retail banking to commercial banking to brokerage and to other things that we see. And the other thing that is also important, we didn't mention that, but every large institution today is trying to limit the number of vendors he's working with. And they're trying to, again, for security, for confidence, for efficiency. And what's unique about these large organizations in general, that there was an evolution, and many different teams, and each team may have used different testing framework, developed its application, this guy with JavaScript, this guy on C#, etc., the .NET framework. And these customers, these big banks, in our case, are looking for a testing solution that can accommodate the needs of all the different groups that use different tools. And in some cases, by the way, we see codeless tools side by side with code tools, code-based tools. Like we see Selenium with some codeless tool. And we need a testing framework that allows combining all of that and providing one dashboard for all the groups in the organization. And as I mentioned before, because we see those SDKs that we have for like 50 plus different tools, actually that helps us because banks are looking for that one platform that can integrate all the different tools that has been used so far and probably will be used in the future because there are always new tools that are being added. So what's the best way to kind of like add them into the organization without adding more vendors? It's to use one tool that concentrates all of them, and that's one thing that we provide and we see in these organizations.
And of course, you mentioned security requirements earlier, the VPN requirements, and that Applitools is sort of unidirectional in that sense.
Exactly, yeah, and especially like as the trend is moving more and more to the cloud, that part is really critical. And in many cases, we kind of like when we start talking with the bank, so we say like, first of all, evaluate what you need from a security perspective. And in many cases, that leaves us as the only vendor that can provide the right solution. But yes, that's very important. Yeah,
and we hear all the time at our events how DevSecOps and security requirements generally are becoming a priority, particularly for those large financial firms that are well established in their digital transition. The focus for them now, many of them, is DevSecOps. Another question, couple of questions coming in, Gil, I'll forward them to you. What trends are you seeing in the market around device proliferation? And how are companies testing across different browsers, devices, and incorporating that requirement into their CI, continuous integration, continuous delivery pipeline? Yeah, I guess this is a continuous challenge for all firms and financial firms, the sheer number of devices that their customers are using.
Yeah, so we actually, this is, I think, the third year that we ran a survey with many different companies, not only in the financial sector, all across the board. I can share some of again, we're going to publish the full results of that survey that we did, which includes 20 plus different areas, but I can only focus on a few of them. Let me share my screen here again. I'll jump quickly. So the survey that we ran, we just ran a few months ago and now kind of organized the results, covered more than 820 respondents that vary from individual contributors, team leaders, managers of larger team, and engineering managers. Because again, we didn't talk about it, but who's responsible for quality today? And that's really a wide range, from dedicated QA teams to the responsibility shifting to the VP of engineering. In many cases, today we see heads of user experience and heads of digital. For example, when we're talking about digital banks, we see in many cases someone that is just responsible for the digital transformation. So there are a lot of people that are responsible for quality these days. Sometimes there's overlap, and it's very different in different types of organizations. But we covered many of those. And again, I'll jump into to show the actual results that are summarized here, but I'll show them one by one. So, only 50% or less than 50% of, I would say, software companies automate today more than 50% of their tests, which is, still there's a lot of room to grow. But the good news is that only less than 15% of companies are using no automation and going only manual. And we see that increasing. By the way, in banks, automation is growing faster, and most banks are over the 50% automation, but still there are, and there should be, and I'll talk about it when we talk about autonomous, there should be some manual testing. I don't see like 100% of testing becoming fully automated. It will take some years before we'll get there. So that's one thing. Now, you asked about what are the main targets or goals that companies are trying to achieve with automation. And we see that, again, it's improved the test coverage. And we're talking about large number of applications. We're talking about financial institutions that have sometimes more than 60, 70, or even 80 different applications. And they want to get coverage, very high coverage of these applications. So this is probably the highest ranked target. Then reducing the number of escaped bugs, which is, again, better quality at the higher coverage. And the third one, there are two contenders, increase the release velocity of software, which is actually directly connected to minimize the test maintenance. That allows companies to actually move forward with changes and requests or answering requests of their customers. We also see a significant shift from to accelerate the number or the number of tests that are run. And if in the past tests were run many years ago, 3 or 4 times a year, and then every 2 weeks when we got to Agile, today we see ICD, we see more and more organizations, in this case, more than 35% running daily or even more than once in a day. And we see some of our customers and some of our financial institutions runs up to 5 times a day, like a full test. I mean, I'm not talking about partial tests, which they sometimes run more. So we see the trend of shortening the test cycles in more and more of the customers. Still, the largest number of applications that are being tested are web applications, but the number of mobile applications and the ratio between web and mobile is changing. And when we compare to previous years, we see more and more mobile applications. And I guess that in 2 or 3 years, it will become even, and mobile can even prevail in that respect. And again, to the point that you asked about the number of browsers. So with the number of browsers, we actually see some stabilization around 3 to 5 different browsers. It used to be in the past, we saw many more browsers, but I think that the standardization that the W3C strict standards have generated in the web application space actually made it okay to run over up to 5 browsers. Again, there's more, they're running on not only Chrome, but now other browsers as well are running on Chromium. So that kind of contributes to that. And we see some stabilization here. While with mobile devices, even though there are still companies that don't test on more than 1 or 2 devices, and sometimes when we talk about 2, we talk 1 iOS and 1 Android, the demand and the need is to run on many more devices. And this would increase with device proliferation because there is no standardization in the device field right now. And again, it's very different when we're talking about iOS and Android, but each one has its own specific variants and issues. And I think the number of devices is actually growing and will continue to grow in the future year, which is, again, not in accordance with what we see in web, but that's what we see. And again, the last slide here is, the question was which part of the testing processes you are planning on supporting with AI in the future. And definitely it's a very clear, I would say, trend or wish. People want to add more AI. They understand that this is critical to be able to meet the speed, the quality, the user experience that they expect. And they expect to see AI playing in different areas. We're talking about, visual regression is one thing. And again, visual AI, of course, is the key type of AI that can do that. But they're also talking about test management and test execution. And without getting into the detail, I would say that they expect AI to actually tell them which subset of tests they need to run after they make a code change, because today they have tens of thousands, especially the large organizations, of tests, and one way to accelerate execution is to run only the tests that are being affected by the changes that have been made through this version, and AI can help do that. And again, something that they are still is early on, but I expect to grow, is test authoring. We are, as Applitools, looking into that space, seeing how we can use AI, analyzing the application itself to automatically create or author tests with no need for a QA or a developer to do so. So still very few, not a large percentage of customers, only 25% of customers see that as a need today, but we know that this would grow as people would become more aware of the possibility of AI to actually write tests. Yes, and again, I can answer a few, if there are more points.
Yeah, thanks, Gil. Yeah, I know you want to talk a little bit about autonomous testing as well. Before you do, we do have a question that one of our audience has sent in. And I'll just read it straight out. How is visual testing? How is visual AI different from bitmap? What's the comparison?
Okay, so I think it was clear in the example that I gave with the Chrome and the Explorer example, where we can see that different browsers and different devices actually can render the pixels very differently. If you took those screens that I mentioned before, or that I showed before, it has up to 2,000 different pixels. So if you do pixel to pixel matching, you would catch a difference. Now, people have tried to overcome this issue with some sort of filters. Let's say if it's less than 50 pixels difference, then it's okay. If it's more than 50 pixels difference, okay, that's a problem. But the thing is that if a plus changes into a minus in your bank account, it can be only like a 3 pixel difference, but it can be a $2 million difference. So you don't want to miss that. At the same time, if a lot of pixels are changing, but the human eye sees the same outcome, you don't want to detect that as an issue. And the thing is that with visual AI, when we use machine learning, it actually helps us through the feedback that we get from customers. When we show them a problem and they say, okay, that's a real problem or that's a false positive, actually the algorithms learn, so they improve over time, and it creates significantly, like the difference between false positive rate between pixel matching and visual AI is between 1 to 1 million to like 10 or 15%, which is a huge difference in every aspect.
Okay, thank you. For the last couple of minutes of this seminar, Gil, let's go broad again, because I know you've got some very interesting comments you want to make about the potential in autonomous testing and low code, which you see as a big trend, for the next year or so. And I know that this is something that a lot of financial firms are looking at, they're talking about at our events. I'll hand back over to you, and you've got some very interesting slides on this.
Okay, yeah, so I'll continue with the sharing. And again, just to begin with, you know, the wish or the wishful thinking is, you know, let's instead of like writing scripts or do record and playback, let's just tell the autonomous testing, test my application and let it do the work. So, you know, that's the ideal situation. I don't think that this is, I mean, it's a good North Star, but we're not going to get there, you know, directly or soon. It will take years, but we will go in that direction and make more and more of that happening. So, and again, how can, you know, autonomous testing in my mind is like testing without code. And there have been a lot of approaches that we talked before about visual AI, like pixel matching, and then make it like visual AI. So there's been some development. It started with like monkey testing. Let's just hit every button and put every value possible in every field, to let's use a sitemap, or let's record and playback, and then let it run again, or let's track user behavior and build a test accordingly based on that. And each one of these approaches has its pros and cons, but none of them is autonomous. And I think the direction is how to kind of like use AI to kind of integrate between those different approaches and add additional insights, like being able to analyze the screen and understand what are the different you know, buttons and fields, and what is the expected contact or the expected action, and then generate tests, generate test code, and of course inspect the results. And again, the idea is how can we, instead of writing a lot of code, actually do something that automatically detects that this doesn't look right, okay, without needing to validate every element or field on a specific screen. And very high level, we've seen a great example happening with driving, autonomous driving, and all of us seen, you know, the Teslas and with the automatic navigation, etc. But we also read about some accident that happened, and, you know, life that ended because of mistakes. And so again, it says that you can start generating these algorithms and they can start working, but they need human supervision still and human enhancement. But that's the idea. Now, when we look at autonomous driving, the thing that eventually is working is taking a camera, and now it advances to radars, etc., but some sort of an image of what's going on in the road, traffic, signs, the road itself, etc., and classify those items, determine what are the relationship between someone that is crossing, you know, the street and the lights, etc., and take an action. And autonomous testing actually does something very similar, at least in our approach of using visual AI, because instead of using a camera on the dashboard of the car, we actually use a screenshot or a snapshot of a screen taken from the application. And by the way, it can be on any device, and we mentioned, you know, mobile devices and computers, but we also do that with PlayStations and other, everything that has visual output. We can just take a screenshot and analyze it. And again, instead of like analyzing the cars and the road, etc., we analyze the different fields on the screen, classify the elements, understand the relationship, and then take action. So I think that's basically what we are foreseeing. But we understand that, you know, it's going to be implemented in steps. So we are taking it one step at a time. One thing is kind of like analyzing the visual elements on a screen and understanding the relationship and the action, etc. Another approach is to use the design, like taking the output of a design tool and understanding all the scenarios that have been put into the design and all the different screens and the paths from one screen to the other, etc., and implement that to test as well as other things. And that's what we expect seeing out in the market, where I believe that like in a matter of a year or year and a half, we will be able to release like the first, I would say, prototype or even a product, minimum valuable product of an autonomous testing, where today we have the validation portion ready and working, but we need to build the navigation, automatic navigation through all the different use paths of the application.
Fascinating. Gil, thank you very much. Thank you for looking ahead as well as what you're doing currently. That's a great place, I think, to stop. And of course, I hope we'll be talking again soon and catching up on how autonomous testing is developing in practice. Thank you very much indeed for your time.
You're welcome. Thanks everyone for attending.
Thank you for coming, everybody. Goodbye.